Alright, hi, this is Mrs. Finnegan, and we're going to be looking at questions 33 and 34 from the Semester 2 final review for pre-calculus. And so now we're going to be looking at graphing rational functions, and as discussed in some earlier videos, rational characteristics, we're going to use RETEY, RATI. R stands for roots, and we find that when we set the numerator equal to 0. A stands for asymptotes, which are vertical asymptotes, and we find those when the denominator equals 0. T, or t squared, is tangency or togetherness, and that occurs when you have a factor squared. If you don't have a factor squared, then you don't have either, and depending on where your factor squared would determine which one you have. Factor squared in the numerator gives you tangency, a factor squared in the denominator gives you togetherness. E stands for end behavior, and that's when you have a ratio of your lead coefficients. You say y equals the ratio of your lead coefficients and you simplify. And the y stands for our y-intercepts, and we find that when x equals 0. So we're going to sketch a graph of y equals x minus 2 squared over x plus 1 times x minus 3. So let's identify our RATEY. So first we're going to start with our roots, and that's where we set any factors in the numerator equal to 0. So x minus 2 equal to 0 is going to give us a solution at x equals 2. And since it's squared, something special is going to happen when we get to the t. Alright, now our asymptotes, we're going to do the same thing, except now we're going to set our denominator equal to 0. So x plus 1 equal to 0 is going to give me an asymptote at x equals negative 1. And x minus 3 is going to give me an asymptote at x equals positive 3. Okay, remember our roots or asymptotes are going to be opposite of how they appear in our factor. Alright, so for t, remember that's our t squared, if you want to put a little 2 there. We do have a factored square in the numerator, and anytime you have a factor squared in the numerator, it creates tangency. That's a double zero, a duplicity in our solution. So that means we're going to have tangency at x equals 2. So whenever we get to that root, we're going to bounce off it, we're going to turn around. Alright, our end behavior is going to be a ratio of our lead coefficients. So I'm going to say y equals, okay, in the numerator I have x squared. And in the denominator I'm going to have x times x, which is going to be x squared. Okay, so that's over x squared. And if I simplify, x squared over x squared simplifies to just y equals 1. So that means my ends are going to flatten out at y equals 1 as x goes to infinity. And the last thing is going to be my y-intercept. That's going to happen anytime when my x is 0. Alright, so if I plug in a 0, don't forget when you square a negative sign, such as we have in the numerator, it becomes positive. So my y-intercept is going to be at negative 4/3. Alright, so over here, over on my x and y axis, I'm going to plot all of my roots, asymptotes, and my y-intercept. Alright, so I have my x-intercept plotted, and I have my y-intercept, and I've put dashed lines in there for my vertical asymptotes to help me give me a reference. Alright, so I'm going to start here in the section where I have 2 points. I have to cross through this y-intercept and connect with my x-intercept. And remember, at my x-intercept I have a tangency point at x equals 2, so that means I'm going to turn around and go the opposite direction. So that means that I'm going to have to keep going down there, and on this one I have nowhere else to cross through, so it's going to keep going down. Now, to decide where you're going to start on the opposite side of each of these asymptotes, since I do not have any factors squared in the denominator, there is no togetherness with my asymptotes. That means that my line, instead of starting together at the bottoms, they're going to have to begin at the top. Alright, so I start at the top. I just noticed that I had forgotten originally to graph my horizontal asymptote, my end behavior line at y equals 1. That's important now as we get to the end. So I come from the top, and as I approach that horizontal asymptote, I'm going to flatten out because I cannot cross it as I go toward the ends. Okay, same thing over here on the right. There's no togetherness at x equals 3. So I'm going to start at the top, and then I'm going to go out to the ends and approach that asymptote. And let's put some arrows on there to represent that it keeps growing. And that is the graph for question 33. Now we're going to do the same thing on question 34, but you'll notice that the equation that we're given is going to not be factored this time. So before we can do our RATI, we need to be able to factor our equation. So if you look at the numerator, I have x squared minus 1. In factored form, that's a difference of squares. Hopefully you're comfortable with that now. I'm going to have x plus 1 times x minus 1. And in the denominator, x squared plus 4x plus 4, 2 times 2 is 4, 2 plus 2 is 4x, and so that's going to be my two factors for the denominator. So since I have the same factor in the denominator, I'm going to shortcut it and write it as x plus 2 squared. Alright, so our factored equation looks like this. Alright, so again, we're going to go through and find our RATEY. So R stands for roots, so our numerator is equal to 0. X plus 1 is going to give me a root at -1, and x minus 1 is going to give me a root at +1. And remember, those are x equals values. So x equals -1 and x equals +1. Our asymptote is going to occur from the denominator, so x plus 2 is going to give me an asymptote at x equals -2. T, we do have a factored square in the denominator, and anytime you have a factor squared in the denominator, that means your asymptotes are going to be together at that point. So for t, we're going to be together at -2. Alright, so that affects when my asymptotes approach the line, they're going to approach the line together. Alright, so for my end behavior, I'm going to create a ratio of my lead terms. It's easy to see my lead terms when it's an expanded form, x squared over x squared. Since it's the same on both the top and the bottom, it's going to simplify to 1. And then our y-intercept, I'm going to again use my expanded form to make it a little bit easier. It's just going to be the constant from the numerator over the constant from the denominator, which is going to be -1/4. Alright, so I'm going to graph my x-intercept, my y-intercept, my horizontal asymptote, and my end behavior asymptote on my graph. Okay, so I have my asymptotes, both my vertical and horizontal. I have my x-intercepts and my y-intercepts. So now I'm going to graph my line. I'm going to start here with these, and one thing I do want to point out is that this horizontal asymptote affects only the end behavior. So it's okay to cross over it in the middle of the graph, because the only way that I can connect my two x-intercepts by going through the y-intercept is to kind of go this way. Let me redo that so it's not as messy. And there's no other place that I cross the x-axis, so this line is going to have to keep going up, excuse me. And so I have to cross over this horizontal line in the middle, but it's okay to cross the end behavior asymptote in the middle of the graph. It is not okay to cross it at the end of your graph. So it's going to go up. So notice over here on the right hand side, there's nothing else that I have to cross. There's no other asymptote, so this means that it's going to approach the end of the graph, so it's going to level out on the bottom side as it goes to the right, because it's going to go to infinity. Alright, over here on the left, as I approach the asymptote at x equals -2, I have to cross over to the other side, and so this is where the t comes into play. I'm together at -2, so that means if I'm going up on the right side, that it's coming from the top on the left side. And then as it approaches this horizontal asymptote, there's no other x-axis crossings, and so that means it's going to level out on the upper side of that end behavior asymptote line. And so this is what the graph for question 34 will look like. So make sure that if it's not factored, that you factor it first, and then you find your RATEY, and then just plot all your important points and draw your graph on your axis.